Here is a tutorial on how to perform analysis on calcium transients data using LabScribe's add-on Calcium Transients Module. First, we will want to create a smoothed channel off the raw data channel. Click FX, then click Smoothing, and the Smoothing dialog window will pop up. Here we can select the smoothing type. Smoothing is used to remove noise that is uniform across all frequencies. LabScribe uses two different algorithms to smooth the data. The moving average function does wide smoothing, while the Savitsky-Golay function seeks to preserve shapes of peaks. We will select the Savitsky smooth. To use the Savitsky smoothing function, the order of the polynomial and the number of points on each side of the data need to be specified. Enter into the text box the number of points that should be averaged on either side of each data point. A higher moving average will result in a smoother signal. Press OK to add the smoothed channel. To edit the computed channel, you can select Setup Function. Next, we will open up the Calcium Transients Analysis Module to perform analysis. Go to Advanced and select Calcium Transients. The module will open. Across the top of the dialog, in the Channel Display area, is the calcium data channel from the recording. The tabbed configuration dialogs are on the left below the recordings. An XY graph window on the right displays the current calcium transient. Between the configuration dialogs and the XY graph window is the Cycles Selected list, an editable list of the cycles that can be displayed and analyzed. The data table is located on the lower part of the dialog. First, select the calcium channel to perform analysis on. We will make sure the smoothed channel is selected. Next, set the cycle duration in seconds. Choose the percentage above baseline up to which the program should try to fit the data for calculating tau. The software uses this value to calculate the curve fit from the min-d cursor to the percentage above baseline. Choose level A and level B. These correspond to the two horizontal cursors above baseline. Choose the rise-fall time percentage of baseline to max. 10% to 90% is most commonly used. Set the baseline. We want to set the baseline at the flattest section of data. Here we will set the baseline between 13 and 16 seconds. Lastly, set the cycle detection sensitivity. This is how sensitive the software will be when detecting cycles. When the parameters are set, drag the cursors at the top of the screen to recalculate the data. The text box below the set parameters displays the calculated tau values for each cycle. The data table at the bottom of the screen displays the chosen calculated values for each of the cycles checked in the Cycle Selected window, as well as the mean, standard deviation, and range of each of the chosen parameters averaged over all the selected cycles. All the calculated data in the data table can be copied to the clipboard by clicking the Copy button, or exported by clicking the Export button. Clicking Algorithms opens an information window describing the mathematical equations used to compute a number of the offline parameters. LabScribe is able to calculate a large number of lymphatic contraction calculations for each cycle. By clicking Table Options, the calculations to be displayed in the dialog data table can be chosen from the list of all possible calculations. Clicking Load Template or Save Template displays a dialog allowing you to name and save a specific configuration for future use, or to load a previously saved template. The XY graph can also be copied, and the average data can be exported as a tab or comma-separated text file. Clicking OK in the Offline Calculations Options dialog saves the settings for future analyses.